Today, we're going to take a look at section 1.9. So we're continuing our exploration, if you will, into different models. So far we've had 3 different models. Tell me one we've had. Linear. What was the one you said? Logarithmic. And exponential. Those are the 3 we've had so far. So today we're going to add on 2 more models in 1.9 and 1.10. So 1.9 is quadratic functions and models. So in the calculator, this is called Quadrag for quadratic regression. And the equation looks like this. F of x equals ax squared plus bx plus c. And you should be aware that the a value could not be 0. B and C actually could, and that'd be okay. It would be unusual, maybe, for the kinds of problems we deal with. But they actually can't have A as 0. If A were 0, it would mean that this whole term wasn't here. And if I only had this piece left, what kind of model would I actually have? It'd be linear. Exactly. And that's the reason why A can't be 0 for it to actually be considered quadratic. Couple of features in a quadratic model. For sure, you have only one concavity. So it is either concave up, means it looks like a U shape, or it ends up being concave down. And we flip it upside down. You may see a change. There's a typo here. This should not say in concavity. You may see a change from increasing to decreasing or decreasing to increasing. So clearly the pictures I drew, you see that.
Oh, so you said there's only one concavity?
Yes.
You might see a change?
A change, and I scratched off the part that was wrong.
Oh, okay.
It should say a change from increasing to decreasing or decreasing to increasing.
What's that point called? Isn't there a name for it?
The maximum or minimum point. Or you can call it relative extrema, and it covers both. Yeah, and we'll talk a lot more about that point later, actually. So let's say, for instance, your scatter plot looked like this. It's definitely concave up, right? It is. It only looks like maybe half of a parabola. You might think it looks exponential, and it kind of does as well. But it also could potentially be represented as quadratic. So this would be an example of a scatter plot where you don't see it go from increasing to decreasing or decreasing to increasing. There's just one feature. It's only increasing, but it might still be represented well with a quadratic equation. Okay? So that's what it's referencing or talking about on part 2, on the second step right there. All right, so here is an example of graph, kind of like the one I just drew, actually. It says, more generally though, what type or types of function or functions might be appropriate to model the data represented by the scatter plot. And we have 4 options because we've only talked about 4 options: linear, exponential, logarithmic, or quadratic. So could we represent this with linear modeling? No. This doesn't look anything like a line, right? I definitely have concavity, so it's not a line. Could it be represented with an exponential model? Actually can't. Does anyone know why? Martin?
Because it's concave down.
Yeah, exponential models are always concave up. So our 2 exponential models look like this. They open upward, so it can't be exponential because this one opens downward. Could it be represented with a logarithmic model? Martin?
I have a question.
Yes.
How can we difference the exponential model open up and the logarithmic model open up?
We'll figure that out later. That's a good question, and I will explore that later with you, I promise. Okay, so could this one be logarithmic? Do you have another question, different?
I do. So I just submitted
just spit back out and say it's late or something. Don't worry about it. I go in and fix those after class. Yeah. As long as you're doing it when you're supposed to be doing it in class. Like if you do it like, 2 hours later or something, we're gonna have problems. And I'll probably send you an email and say, hey, what's going on? But for right now, it's not a problem because it shows up in the system what time you did it for me and I'll know.
My phone is in charging, so I don't put it there.
It's okay. We'll get there. You're fine, Martin. Okay. One more time. So many fun things to talk about. Logarithmic model. Could it be logarithmic? It actually can't. Do you guys remember what the logarithmic models all look like? So in particular, the problem that fails here is logarithmic models always have a vertical asymptote on the y-axis. All right, so this one does not have a vertical asymptote along the y-axis, right? It just doesn't have one. Visually speaking, our two logarithmic models look like this or like this, and this doesn't have that feature. So in other words, if it's concave up, it has to be decreasing, and if it's concave down, it has to be increasing. And ours is concave down and decreasing, which is not a feature. So we've ruled these all out. Could it be quadratic? It could, and if you imagine, it would simply be half of a parabola. That's a terrible parabola, but you have the right idea, right? It'd be half of a parabola. So that's actually the only one here that it could be is quadratic. There might be cases, though, like Martin asked, well, how do we know if it has two options? Where it does have two potential options. It might be quadratic or logarithmic, or quadratic or exponential. There might be some choices. So just be aware that the answer is not always just one and only one answer. All right, we got one more. What types of functions might be appropriate for this one?
Just quadratic.
Yeah, we don't even stand any other chance of talking about anything else, right? Every single other function we have is solidly increasing or solidly decreasing the whole time. This one changed directions. It's decreasing and then it's increasing. So the only option we even have to consider here is that it's quadratic. Okay, if you don't have it out already, go ahead and grab your calculator. We have a chart here. The following chart shows the profit a company makes when selling blenders. So we're going to put in our scatter plot. So the lists, L1 and L2 list underneath the stat menu, these data points. And again, this is kind of like the one that Savon was asking us about at the beginning in terms of do we change any data points, and we won't in L1 or L2. We never do in L2 anyway. But in L1, we won't change anything because we're not dealing with any dates and we're not told that we have to change anything. So we will list them exactly like they are. So I have 14, 17, 20, 23, 26, 29, 33. Part A asks, is a quadratic model appropriate? So we answer that question by doing what we did back on A and B. We have to look at the dots, the scatter plot, in order to make any kind of a declaration one way or another. So if you hit y equals, clear out anything that's in y1, and just hit zoom 9 to stat plot your graph. And mine looks something like this.
Probably helps if you turn your plot on, right?
Definitely helps if you turn your plot on. Yes. Now, one of the reasons it's useful, even when you're not sort of given a question like this, to go ahead and turn the graph on and check it before you start calculating things, is to make sure you didn't make a typo. Because let's say, for instance, you did this and all of a sudden when it pulled up, it looked like that. Sort of be a red flag that, hey, I may have entered something wrong. So you have an opportunity to go back and fix an error that you might have had that you data entered too quickly. This is what I have. So is a quadratic model appropriate? Yes. Why?
It's increasing and then decreasing.
Perfect. It's because it is increasing then decreasing. Those are my abbreviations, INC and DEC. And then, of course, it says, so find a model. You guys are getting good at finding models, aren't you? Okay, because this is one of those things, right? The more you do it, the easier it becomes, right? Like learning to ride a bike and things like that. You do and do and do and do, and all of a sudden you just don't think about doing it anymore. So we'll get to that point if you're not quite there yet. Your data is already in, so you're going to go on the regular screen, Stat Calc, and it's option number 5, okay, Quadrag. Make sure you're telling it to put it into Y1 and calculate it. Let's see, we're doing blenders, so we'll call it B of X. You can call it whatever you want. You call it P of X if you want to do profit. Or you can just call it F of X all the time. With 3 decimal places, I have negative 1.808 x squared plus 100.326 x minus 934.223. Name equation. I am not done. Right? Name equation, I'm not done. What comes next? Output. And it's in the table, right? The output right there, it's dollars. If you want to be more specific, you're welcome to say dollars of profit. But as long as you say dollars, you're good. After the output, what do we put? The input. So what is the input here? Blender sold. So we say when X is, because you're defining that the variable does something, when X is the number of blenders sold. That is not a hashtag, that is a pound sign. Just reminding. Yep, that's our next step. What's our data range?
14 and 33.
Yep, that is our very last step, Mark, and I just barely had enough space on my screen. And then we have our data range, like Mark said. It's okay? All right. Question C says, why could they profit less when selling 29 blenders instead of 26? So this is not a calculator question. This is a question related to business, right? If you look in this particular table, they sold fewer blenders, 26, and made more profit, 451, than when they sold more blenders, 29, and made less profit, 446. What are some ways in which that could logistically really happen in a business?
Too many blenders on the market.
Okay, so if you had too many blenders on the market, what does that do? The price drops. There's something about the price that happened. Right? That seems like the most reasonable thing. Is that one option is that the price drops either because there's too many of them on the market, or maybe it's because they had a sale and they wanted to get rid of them off the shelves. They need more shelf space. Y'all know stores do that, right? They clear out shelf space when certain things come in.
So,
There's one other thing that happened too. Yes, Mark?
is that why people, like companies will do, they'll do like limited, sales of the product, like Yeezys, they'll only drop so many pairs on
Sometimes.
a certain day. Do you think that's to maximize, like, as opposed to if they just made a whole bunch of them?
Yeah, definitely when you overproduce things, it does not always result in more profit. So you have to be really careful when you're producing things. There's also one other thing that might have happened. Another possibility that it might cost additional to make more. So, for example, we have a mission organization in Ethiopia, and every year or so, my husband goes in and he has a mass run of t-shirts that we produce for that mission organization, and then we take them with us over to Ethiopia for them to sell to people who come through the organization wanting to support them, right? So if we have somebody right now, like this actually happened a couple of weeks ago, who called us and said, do you have any t-shirts? Well, we don't. They're all in Ethiopia right now. We don't have any t-shirts stateside to be able to sell them. And it would make no sense for us to produce one shirt. Okay? If you've ever had production run for anything like that, that's very expensive to do a production for just a small number of things. So sometimes the production costs are different depending on what's already been produced or is going to be produced later. All right, one more question on the problem. When will the company begin to post a negative profit? Okay, so negative profit doesn't mean that they are having negative money. It just means that their costs and their revenues equal each other, right? They spent as much as they made. That's not a good position for a company to be in, but it's better than a negative position. So when would we be looking for in terms of this calculator? We didn't even graph it. I didn't anyway. Did you graph it to make sure it looked good? Okay, mine does, so that's good. So in terms of my graph right now, if I were to sort of fill in what's on my screen, it looks kind of like this. Does yours look like that? Wonderful. So what would I be looking for visually on a graph for my profit to post a negative profit? It needs to go below the x-axis. I have no idea who said it, but somewhere back in this corner. You're exactly right. Needs to go below the x-axis. Well, in the screen I'm looking in right now, I don't see the x-axis, right? So I need to zoom out from my screen in order to see the screen at a bigger view. So I'm just going to zoom out. So zoom 3 and press enter. And sure enough, when I do that, my image now ends up looking like this, roughly. And the part of the graph that we know is sort of honestly there is at least this part, right? So I'm looking for this location here. Does that blue show up at all? Barely. Change off to a different color. So we're looking for this location right here, right? So how do we do that? Well, actually, you've done it before, you just didn't know it. So right now you've got your equation in y1. This is the equation you already have. In y2, I'd like you to put the number 0. This is one way of doing it, most closely resembling what we've already done, so we're going to do it this way. y2 is equal to 0. Now you're not going to see it graph it, but what it's going to do is, we'll do it in orange, is it's going to put a line right here. So now the line there and the curve here are actually going to cross. And we have a way to find a crossing spot, an intersection with our calculator. And we've done a number of times together now. It's second trace, option 5 intersect. Now, you need to be careful because it crosses twice. Yes, Simon?
I'm having trouble graphing.
Okay, let me come back there. So one of the things we want to notice then on this, though, is that we want to find, like you said, the second location where it crosses. So when I tell it to do second trace and do 5 intersect, and it says first curve, second curve, those are no-brainer enter twice. Well, we need to be closer to the point we care about than the point we don't care about. So you need to arrow over when it says guess to be near enough to the point that you care where it intersects so that it will capture that x value and not the other one. So if we do that, my calculator tells me that this value is x equals 43.644. Okay, that's what we're looking for. But remember, what does our x value represent in this problem?
Units.
Of what?
Blenders.
Blenders. So can I say 43.644 blenders? No. So I need to decide, and this isn't a regular rounding rule even thing, is it 43 or is it 44? When will they post a negative profit? At 44, and not because I've rounded. They will post a profit of negative at 44 because 43 is still above the x-axis, right? So the answer is at 44 blenders. And again, how is that possible? Well, they probably had to lower the price or their costs increased to such an extent that it was no longer profitable to sell that blender for whatever reason. Any questions on that? Okay, that's it for 1.9.